So this is the work we've been doing with the University of Leeds to basically work on their kind of a whole new replacement infrastructure, because like many people, they have lots of systems of various ages and like states of disrepair, and they wanted to kind of do a fresh start with digital preservation and the presentation of all that stuff online. So this whole project is called DLIP, Digital Library Infrastructure Project. I'm not going to talk about that because I could be here for hours talking about the whole thing. But really, there's these three pillars, these three open standards. One is IIIF for like showing the stuff to the world. One is Linked Art for describing it. I'm not going to talk about that, but I would mention just from the end of the last presentation that Linked Art is a kind of a user-friendly subset of CDOC-CRM. So it's kind of an interesting thing for cultural heritage institutions to use as to model data for sharing. But I'm not going to talk about that any further than that. Really, the crucial thing here is obviously OCFL for storage. So you've got IIIF at one end for interoperability of content, and OCFL at the other end for, I guess, future interoperability and recovery of the raw materials that generated that content. And so what the key thing about Fedora here is that it's our gateway to OCFL. And so we're kind of maybe coming at it as new Fedora users, where the OCFL-ness is actually the kind of key selling point. So the Fedora API has lots of nice features that we can use, but the important thing is it's writing OCFL to disk. So just to summarize the whole thing in a few words, we built some things around Fedora because we're not going to kind of just use Fedora naked as the system that other systems can write and store stuff to. We developed a storage API which just exposes a few Fedora concepts, but in a very kind of simplified way for other things to build on, but also surfaces some of the OCFL-ness a bit more. And then the key thing is this preservation API, which understands workflows and things like nets files and kind of the tools you might run. So it's kind of, whereas the storage API kind of looks towards Fedora, preservation API looks towards Leeds use cases and actual things that humans do. And then there's user interface on top of that preservation API, excuse me. And then various bits of glue that kind of tie events within the preservation API to other systems that can pick up the fact that something's new or changed and build IIIF resources from them. And here's a diagram that basically illustrates that. We've got IIIF on the left, giving stuff out to the world, OCFL on the right, and Linked Art coming in the middle to kind of decorate the IIIF manifest that get created with semantic metadata. And really, yeah, I'm just a brief word. So the IIIF component of it is something that we've developed already and is being used by quite a few different people. And it basically turns your stuff into IIIF. So that bit is a kind of almost off the shelf component. But the other end, the preservation, is what I'm going to show you now. And I think it would be better to just kind of show you how it works. So I'm going to switch to a live demo of the system, which may be a thing I'm going to regret. Where are we? Here we go. So can you now see a sort of user interface? Yeah. Okay,
yeah,
cool. Right.
Yes, you can. Yep.
So yeah, so I'm not going to show you much of this at the API level. I'll show you the kind of UI that we built on top. So some of the main consumers of this system are going to be other scripts and tools, and like the GUI workflow management system and other ad hoc scripts. But there's also a user interface for people to do kind of ad hoc preservation. And I was going to show you, so I'm going to just make a container in here. Let's call it virtual showcase, maybe. And in here, I'm going to say, right, okay, so we've now, oh, there it is. We've now got an empty container, and I'm going to create a thing called a deposit in it, which is basically a kind of workspace for assembling content. So I'll call this virtual showcase as well, not very interesting. So I'm just going to create this. So this isn't doing anything Fedora just yet. It's just giving me a kind of working space where I can, well, I just add some images to it. And if I was being extremely kind of slow about things or had a very simple object to create, I could just add the images one by one, or add whatever the content was one by one in this user interface. But that's going to get very tedious very quickly So what we wanted to do was make sure that we can support a kind of much more flexible kind of workflows. So what's actually going on here behind the scenes is that as I'm interacting with this content in here, I'm actually interacting with a sort of workspace area in an S3 bucket, which hopefully I can go and look at directly in S3. If I'm still logged in. Yes, I am. So this is exactly the same view as this. It's just that I'm now looking at the bucket directly. Here are the two files uploaded. And I could just upload a few more files in here. No, that's not add a folder. Just add a couple of files more. Let's add some cat pictures. Let's just do one little extra step for extra integrity. Let's just check some of them as they go up. So now we're adding some files to here. If I now kind of refresh my view of this thing, I can see that I've uploaded three other files kind of out of band. I could have done that via script or via some other automation or whatever process, but I can come back here and manage it. But I can see there's a distinction between these two, because as I've been uploading stuff, this METS file here has been edited. As you can see, the original two files, or one file, two files, I uploaded mentioned in the METS file, but those two new ones aren't mentioned at all. One of the decisions we took early on was whether to use METS at all, but we decided that actually it solves a lot of use cases for modeling the objects that we want to store in Fedora. So we're not using the modeling capabilities of Fedora at all outside the level of an archival group. We're using METS to model the objects within what the thing within an archival group is. What I need to do now, though, is kind of incorporate those three new files into the METS, or maybe run some tooling on them, because I don't know if you noticed in that METS file, there's very little information here. We've just got a kind of our checksum and the name of the file. It'd be good to run some tools over these, so I can kick that off. This might take a while, but in the background, it's just going off and connecting that area of the workspace, the bucket that I uploaded those things into a kind of tool running environment where it can run typical digital preservation tools like seek-read, ClamAV, and other tools that we'll add over time. See how we're getting on here. This is where it won't be working for some reason, but I'm hoping it will be working just fine. Oh no, it is working, because we can see stuff beginning, some tool outputs beginning to pop in here. Let's just give it a little bit more time. So the point about this thing is that I could, and one of the workflows we wanted to support is the digital archivist using existing kind of workflows based on tools like Bit Curator and basically whatever tools they want to use, be able to work in those environments. In fact, they can do whatever they like in those environments with the files, run Bagit to bag them up and then bring them in here. They're not tied to any particular user interface, but they can just observe what's happened through these user interfaces. Now you can see actually we have a much fuller set of files. We have some output from our tools, but this METS file should now have richer, for example, information like a kind of pronom format identification of these files and various other things. Some antivirus scanning has happened and hopefully reported success on all these objects. So basically what we're looking at here is a kind of workspace that this UI can allow you to edit, but other scripts could edit via the API. And in the future, you might open up a particular deposit to maybe a donor who's just given some material for their approval, just so they can make sure that the stuff going into this object is sensible and what they want it to be in there. And various other kind of collaboration tools as people work on assembling digital objects for preservation. So this is all very well, but this hasn't got to Fedora at all yet. We're just kind of working away in this deposit. So what we do to get it into Fedora is, this is where we kind of our massive simplification of the kind of API. We want to create a thing called an import job. So we've got all this stuff here. We want to create an import job. And in this interface, I've left a bit of kind of background diagnostics here. So you can see the import job we want to do has some containers we want to add, some binaries we want to add, nothing to patch or delete because it's brand new. But basically this instruction, this operation of do this thing to an archival group, in this case, create an archival group, it's an import job. It's a set of instructions to perform some diff operation between the state of the thing now and the state you want it to be. And usually you wouldn't be able to see this, but this is actually what's being sent. And obviously API tools and scripts could send equivalent things. Here is a chunk of JSON that says, I want you to add this container, and I want you to add these binaries, and here are their checksums, and here are their DC titles, essentially, in case they're different from the file names. And also here's where you can fetch them from. Here's where it is now in this deposit bucket. And I want the API to transactionally, using Fedora transactions, turn that into an archival group. So we can do that. Excuse me. I'll just leave that running for a second. We're basically executing that import job, and it's finished because that was a nice, simple Fedora transaction. And it's added these containers and it's added these binaries. And these things are now a real archival group, which we can navigate to. That was in we go back to our virtual showcase, there it is. So now we have some files in Fedora. And obviously this is very simple, but this could be arbitrarily complex folders and file structure with thousands. We'll be testing this with sort of 100 gigabyte deposits with many, many tens of thousands of files in them. It all works fine. But you can see here that this is really now in Fedora. This is a Fedora object. And if I move this over here a second, I've got Fedora open here somewhere. Where is it? Here it is. So if I go via this interface and go into this virtual showcase, there it is. This is the one I just created. So you can see here. This is an archive group, and it has an objects folder, and those are the PNGs that I uploaded. So it really has created this thing in Fedora via the wrong window via this. So what's actually going on? If I say have a look at what's going on at the API level, where is it? I've got one. Yeah. So yeah. So here I'm just running this API locally, but here is the same content. This is actually what's building up the view of the user interface too. There's our virtual showcase container, and within the virtual showcase container is an archival group called virtual showcase. And if we navigate to this is where it gets interesting, because the API. This is where our API is exposing a kind of Fedora containers and binaries type structure, but also some OCFL based information. So this is our kind of extended archival group that has some OCFL like kind of information in it, like this kind of map of hashes. But also for all the objects we have, this is where it actually is in Fedora. This is its kind of OCFL path. Hopefully there are very few, if only one. Clients that can actually access that location because it's safely in preservation, but things like our IIIF delivery mechanism, if that was a PNG or a TIFF or something, could access it there to generate tiles or whatever from it. So our kind of extended model of the containers and binaries will actually tell you where the things are if you have permissions to access the files. So you can see here, where's go down a bit to some of these PNGs. Yeah, like if I wanted this PNG, this is actually where it is in Fedora's bucket in S3. So that's all good. Oh yeah, and also if I wanted to actually stream it, I think I can do that from here. Yeah, if I click on that content, you can see my cats. But usually very few people actually have permissions to stream from there. That's why I'm running it locally. So yeah, and also the activity stream I was talking about. If I go to here, this is an activity stream, and because it's the local one, you won't see the objects I just created, but you can see, these are the event streams that other systems can listen to learn what's happening in the preservation API. How am I doing for time? Oh, it's okay. Let's have a look back here. If I go back to here, yeah, so one of the things that we were doing is, obviously, if I some of the systems that are listening to events happening in the preservation API are then creating IIIF from them. If I go into here and look at some of these ones, these are archival groups in Fedora. Shouldn't take too long. Why it's taking so long? That's weird. It'd be nice and small. Anyway, I'll come back to that. Why is that taking so long? I'll come back to it. If we go and look at, say, back to here and look at the object we just created. So here it is. So say, for example, it's down here. I wanted to do some more work on this. I could say, actually, I forgot to put some pictures in here. So we can go and create a new deposit from this one. It's like, actually, I don't need to export the stuff. I might want to get the files out, but I don't actually need to in this case. So I can just create a new deposit. And that kind of gives me these ghostly representation of what's in there, because it's using the model in the METs to say, well, this is actually the contents. But if I want to add some more files, actually, just make a little child folder in here. So I could just add a few more pictures into the, let's have one or two. Also, this dialog is calculating a client-side checksum and sending it with the form submission, so we know that what leaves our desktop is the same as what arrives at the browser. Anyway, so now we have a couple of extra files. If I create an import job now, then I've got one new container, two new binaries, but I also have a binary to patch because the METS file itself has now got two extra references to files in it. So that's itself a binary that needs patching. The import job's a lot simpler. There's our METS file. If I now run the import, shouldn't take too long because it's, yeah. And now if I go and look at the archival group again, then I should see that there are two versions of it, because the original one is down here. And version 2 now has our new files in it. But what I can do with the other versions is, this is where the kind of OCFLness surfaces a bit. I can kind of compare these two versions, see where they differ. But I can also export any of these previous versions. So I could, for example, say, actually, I want to get version 1 out, or I want to get create a new, export version. Create a new deposit for version 1. Just warns me I'm not exporting the latest version. If I want to export version 2, I can do that safely and create a new deposit and kind of keep on building up the content like that. So yeah, so this is kind of where some of the OCFLness kind of leaks up, because it's actually significant to us to see this version history like this. But basically, we've kind of developed a nice UI that allows people to do some simple digital preservation tasks, run tools, use the Fedora concepts of containers and binaries and archival groups, but really nothing else. And then integrate that with other systems that listen to events in Fedora and can then take it further, start processing things, turn them into digital objects for presentation. How are we doing for time? Oh, I still got a bit of time. If I just go back to the slides very briefly. Oh, actually, let's see if, oh no, it did come through. There it was. I think this is just really huge and something wasn't cached because This was really fast earlier. Anyway, this is an example here, and you can see that if I click the IIIF button, then a IIIF manifest has been created from this object, and I can navigate it and do all these kind of things with it. Because this IIIF builder component was listening to the activity stream coming out of the preservation API and responding to those events and seeing that there is stuff to build. This is not very interesting, this book. Let's move into some text eventually. There we go. But you can see here that it's turned those raw TIFFs into a nice deep zoom manifest and used information from the catalog API to provide some bibliographic metadata, archival metadata for the object. Oh yeah, here we go. So you can see here there are lots of TIFFs in here, and many of these objects were created by not through this UI, but through other scripts that just consume the API directly. I'll just go back to the slides very quickly. Yeah, so just a different view of this diagram. No, I don't want to do it from the beginning, but here we go. Yeah, we have, again, so we've got OCFL at one end, we've got a Fedora instance, but basically nothing really knows about the Fedora instance. It's kind of locked away behind a storage API, and only the storage API is allowed to talk to it. Various systems may have read access to the bucket that the OCFL file system is stored in, but only read access, and only so that they can actually get at that TIFF to generate image tiles or whatever. But certainly the Fedora API is off limits to all other consumers. Only the storage API can talk to that, and that isolates it behind these kind of concepts of imports and exports. But the storage API is pretty simple. It's literally only about storage. It executes import jobs and executes export jobs, but it doesn't know anything about preservation workflow or tools or METS files or the concept of a deposit or anything like that. That's the domain of the preservation API, which has the kind of implementation of use cases for digital preservation work, and is a kind of a tool that can manage the workspace, manage the files in the workspace of a deposit, manage the METS files associated with them. It can read METS files from a variety of sources, but it can write METS files for objects that originate in it. And then on top of that, we have a preservation UI for archivists to use to do some kind of manual work for certain born digital archives where they might want to assemble things by hand and share URLs of works in progress, things like that. So I will stop there because I'm running out of voice, and also for any questions.
Thanks, Tom. Live demo worked. That's good.
Yeah.
Any questions? I'm not seeing anything in the chat.
I could just, am I still sharing?
Yep.
Yeah. Okay. Well, in the absence of question, I'll just say that
Sure.
the kind of this is an ongoing thing. So that, as I mentioned, the kind of collaborative working, the ability for me to send a particular deposit to a donor who I might need to get approval from, or to a colleague. Other things are basically more of the stuff that you might want to do, like assertion of access conditions at various nodes of that tree of content, assertions of right statements. Other things are actually kind of building up more complex structural information that can be used to generate navigation when it reaches the IIIF layer. I should also add that only some of the content that goes in here will actually surface as IIIF, because obviously some of it is going to be secret or copyright or embargoed or whatever. But stuff that is allowed to become open and is image or audio or video or even 3D based will surface as IIIF and be used on the Leeds website. And so, I mean, we kind of developed this for Leeds, but it's clearly applicable to many other scenarios. So we kind of see how it fits in with things that we do already, like the IIIF Cloud Services platform that we already, lots of people use that already. So to see whether this kind of specialist usage of Fedora for this particular set of use cases might be useful to other people too.
Yeah, absolutely. Anything else for Tom? No.
Cool. Okay.
All right. Well, thank you so much.